Okay, so we're going to start looking at the function y equals sine x. Right, I'm going to actually just bring this down a little bit so that I can focus completely on the graph, and that's completely in your vision. Now, if you can see what we've got at the moment, along our x-axis, we've actually taken degrees from minus 360 all the way through to 360, and then we've made markings or spacings of 90 degrees. So what we are actually wanting is for these to be in degrees, all right, and for us to realize that right here in the middle, this is the origin, all right, so this is where the point 0, 0 is, and you can see that this particular graph has got a beautiful flow to it. Now, I'm going to teach you how to draw this graph using your calculator. But once you've drawn it, what you are going to need to do is capture this in your head as being the graph that you will always get when you are working with the y equals sine x function. And it will always have these standard characteristics. Okay, so what we're going to do first of all is we're going to show you how you're going to do this on the calculator. Now, I know that in trigonometry, sometimes you worked with y is equal to sine theta. Now, the theta or the x is exactly the same variable, all right? That is the angle that we want in degrees. So if I were to say y equals the sine of 0 degrees, my input would be 0, and according to the picture, it's telling me that when I put in a 0 degrees, can you see that the y or the output value is a 0? So on this particular graph, it's showing me that, for example, the sine of 90, my input is 90, and my output, according to this, can you see how the graph at 90 goes up and it peaks at the number 1? Now let me show you how you are going to be able to get these values for yourself. Right, off we go to our calculator. Now on your calculator, across the top here on the blue buttons, second from the right, you've got a mode setup. You are going to choose number 3, which is the table. Now it's telling you in function notation f of x. Now that f of x is absolutely the same as y. All right, so that is reading y equals. Now we wanted to read y equals sine of an unknown angle. So we go to the sine, and now we needed to put in an x or a variable. So we go to alpha, and then we go to x. We close our bracket, and so now we've got it reading y equals sine of any variable angle. And we hit equals. Now, it wants us to tell where it must start. Now, according to this picture, we need to start at minus 360. However, in your test or your exam, your teacher might ask you to start at 0 or at minus 180. So that is going to be at the discretion of the teacher or the examiner. But in this case, we're going to put in negative 360 degrees. And you hit equals. Now it asks you where does it want to end. And according to our book, it wants us to end at 360 as well. Now it asks you the steps. Now at the moment, it's programmed to go in steps of 1. Which means that it would work out a value for minus 360, minus 359, minus 349. Now that's a bit of overkill. You can see that our graph is actually doing quite well if we just plot it in 90-degree spaces. So I'm going to say that the steps should be in 90, and then I'm going to hit equals. Now can you see that on your screen it's telling you that at minus 360, the graph should take a y value of 0. And there that point is right there. At minus 270, it should be up at 1. So can you see how the graph travels from 0 all the way up to 1 in a very regular curve, okay? Do not use your ruler and do not go zigzaggy, but just go all the way with a nice hump up to minus 270 matched with 1. Then you can see minus 180 is mapped with 0. And if you now scroll down, it'll then take you to the other values. Minus 90, minus 1, all right, 0 with 0, that one that we had before, 90 with 1, 180 with 0, and all the way down until it hits the last value that you can plot, 360 with 0. Right, so hopefully that's been our clearing for this particular graph. Now we understand how we could graph it. Now the sine graph, can you see, has actually got some really remarkable characteristics. If I just take this piece here, can you see how it consists of an increase, decrease, then decrease, increase? Now that is actually what is happening in the 4 quadrants. So this here is what happens to sine in the first quadrant, between 0 and 90. Between 90 and 180, that's our second quadrant. Between 180 and 270, that's our third quadrant. And that's our fourth quadrant. So our sine graph is pictured here for 1 revolution, and you can see that what it's done is it's taken 360 degrees to complete its course. So often in a test, the examiner will ask you, what is the period of the sine graph? How long has it taken for it to complete one particular pattern? And in this case, it is 360 degrees. Now, that is not always the case. We're going to have to examine each graph at its own merit and see how long it takes for a wave. Right, so we've got 360 degrees. Notice, too, that it peaks and it troughs. Now, you can see that the one peak, or the maximum value, all right, happens at a value of 90 degrees together with 1. And then can you see that it peaks over here as well? And can you see that the distance between those 2 peaks, all right, can you see that this distance here is 360 degrees again? All right, it's 90 to minus 270, so from peak to peak, it's a gap of 360 degrees. So again, we've got another peak in this particular picture at minus 270 and 1. Then we've got a minimum. I call it a trough, but it is normally called a minimum. All right, and this is going to be the trough, or the minimum is going to be at 270 degrees at minus 1. And you can see over here again at minus 90 and minus 1. The other comment that we need to make is that this graph has a span of minus 1 up to 1. It doesn't go below minus 1 and it doesn't go above 1. So you can see that the y values are trapped between the range of minus 1 to 1. And that's another very important word that we need to use. And let's put it in another color just to highlight it for us. And that is the range of the graph. Now the range of the graph is the y values. And remember, we said that the y values come down to a minimum of minus 1, a maximum of 1. So it goes from minus 1 to 1. Now, can you see that that range is 2 units in total? All right? And we use that to get another piece of knowledge, and that is that the height of a bump, all right? You can see that from the x-axis down, so that bump there is 1 unit high. And when we talk about the height of a graph, we use this fancy word and we talk about its amplitude. And this particular graph has an amplitude of 1 unit. Now, can you see again, relating to the range, our range was 2 units in total, from minus 1 up to 1. And our range is half of that. So we took our range, which is 2, and divided it by 1. And that gives us our bump. Right, so have a look at that sine graph and commit it to memory, because these are characteristics for every sine graph in grade 10 that is of the form y is equal to sine x. We're going to look at the a sine x in a bit, and then the plus q in a bit as well. But just commit to memory that it starts at 0, 0, peaks at 91, troughs at 270 minus 1, and completes its course in 360 degrees.